This video is going to show you how to evaluate some functions. So functions can be written multiple ways. This first function we've got here is called g of x, and it's defined for us that g of x is equal to 3x minus 2. We are told that we are supposed to find g of 4. And so what I want to look at is what changed from g of x to g of 4. Well, what changed was x got replaced with 4. So what this is telling us for g of 4 is that x is equal to 4, and we just want to use that value in the expression. So let's go ahead and do that. So g of 4 is equal to 3. Now, we're going to replace this x with a 4, but I need to make sure I use the right operation mathematically. And 3x means 3 times x. So I'm going to use parentheses here. All right, so 3 times 4 minus 2. After this, all you need to do is pay attention to this right side of the problem here and use your order of operations to solve it. So multiplication comes before subtraction. So we're going to do 3 times 4 is 12. 12 minus 2 makes 10. So you would tell me g of 4 is equal to 10. And that's it. So we replaced x, in this case, with what value it was. So x got replaced with 4, and we just simplified the expression using order of operations. We've got a couple more examples to do, and we'll see what those look like. All right, so problem number 2, or example number 2 here, we have a different function. In this case, we have w of n is equal to 3 times these bars here are the absolute value, so 3 times the absolute value of n plus 2 minus 1. And our directions tell us to find w of 3. So I'm going to replace all of my n's with 3's. And how I know that is, again, if I look at this function notation, it says w of n, but now the question says w of 3. So clearly n got replaced with 3, so that's what I need to do in my expression. So 3 times the absolute value of 3 plus 2 minus 1. Now, I exaggerate my absolute value bars so I don't confuse them with the number 1. I have been known to do that before. Doesn't work very well. So we've got 3 times the absolute value of 5. I want to simplify what's inside the bars first. Now, the absolute value of 5 is just the number 5. Okay, absolute value is the distance from 0. And what I need to do is make sure that between the 3 and the 5, I use the right symbol. And I'm not going to add a plus sign because there wasn't a plus sign there. I know this is supposed to be multiplication, so this is times 5. And now you'll notice I changed from the absolute value bars to the multiplication parentheses, so I can move on with that. So 3 times 5 is 15. 15 minus 1 makes my overall answer here 14. So you can either box up the 14, or you can say w of 3 is equal to 14. Either one of those is appropriate. So a little absolute value bar work there. All right, example number 3, we've got a little bit with exponents, some negatives going on, so we need to be careful. So in problem number 3, h of n is equal to this expression, right? It has to be defined for us each time. So negative n squared plus 3n, and we are supposed to find h of negative 4. So every single place I have an n, I am going to replace it with a negative 4. And in this problem, I have an n here and an n here. Both of them need to get replaced. So I've got negative. Now, wherever I'm going to see those n's, I'm going to use parentheses. So n here is negative 4 squared plus 3 times negative 4. Remember, anytime you have a number right up next to a letter like this, right up next to a variable, it means to multiply. Order of operations here, the very first thing I need to do is, in this problem, my exponent. So this negative I'm going to leave alone. And then when I take a negative 4 and square it, that means negative 4 times negative 4. That turns into 16. Okay, and then I've got positive 3 times negative 4. So that would be negative 12. At this point, I can then combine these terms. So negative 16 minus 12 is negative 28. So h of negative 4 is equal to negative 28. Okay, don't get hung up with the powers with your exponents, but be very careful when you deal with your negative signs. Okay, make sure you do the order of operations. So powers first, then deal with any outside negatives. Okay, last example here is going to be problem number 4. And we've got p of n is equal to negative 2 to the n power minus 3. And we're supposed to find p of 0. So every place I have an n, I am going to replace it with the number 0. So p of 0 is equal to negative 2 to the 0 power minus 3. If you've worked with exponent rules before, you know that anything raised to the 0 power, so 2 in this case raised to the 0 power is 1. Now be careful because this negative out front, yes, it belongs to the 2, but the power happens first. So 2 to the 0 power is 1, and then you're going to make it negative. So that turns into an overall answer of negative 4 when we finish simplifying it. So p of 0 is equal to negative 4. All right, I hope this has helped explain a little bit about evaluating functions for you, a couple of different kinds. We had some linear functions, we had exponential, quadratic, a little bit of absolute value, and all of them are completely possible when you are doing evaluating functions. All right, hope this has helped.